Hello, how to solve this exponential problem and find all values of s that satisfies this equation. We have x power 3 equals 1. So I can start by moving this one over here. I have x power 3 minus 1 and this equals 0. I can also raise this one to the power of 3 because 1 raised to the power of 3 equals 1. So we have to raise this one to the power of 3 so that it corresponds to this other 3 here. And from here, we can apply the identity. You have a power 3 minus b power 3. This equals a minus b times a squared plus ab plus b power 2. And in this case, a equals x and b equals 1. So what we are going to do will be to insert these values for a and b right here in this identity. So for a minus b, we have x minus 1 times this is x squared plus x times 1 plus 1 power 2, and this equals 0. From here, I have x minus 1 times x squared plus x plus 1, and this equals 0. So you can formulate two different equations right now. We have this, and this equals 0. I have x minus 1 equals 0. I also have x squared plus x plus 1 equals 0. So right here, if x minus 1 equals 0, I can solve for x. Pushing this negative 1 over here, I have x equals 1. So this is my x1. Now, here is a quadratic equation, and I can solve for the other values of x. So let's solve using the formula method. I have x equals negative b plus or minus square root of b squared minus 4 times ac divided by 2 times a. So the coefficient of x squared here is 1. That is my a. This is my b. And this is c. And the coefficient of x is 1. So I'm going to insert all these values for a, b, and c in this particular formula and solve for x. Of x equals negative b, negative 1 plus or minus square root of b squared x 1 power 2 minus 4 times 1 times c, that is 1, divided by 2 times 1, that is 2 times a. So from here, f x equals negative 1 plus or minus square root of 1 power 2, that is 1, minus 4 times 1, 4 times 1, 4 again, divided by 2. So from here, I can have x equals, this is negative 1 plus or minus square root of 1 minus 4, this is negative 3, divided by 2. So right now, there is minus here. I can simply have x equals negative 1 plus or minus square root of negative 1 times square root of 3, and this is divided by 2. So from here, you can have x equals negative 1 plus or minus square root of negative 1 here is iota, that is imaginary number I. So I'm going to have my I times square root of 3, and this is divided by 2. So from here, I have x equals negative 1 plus or minus I times, this is square root of 3, divided by 2. So right here, I can simply factor out 1 over 2 from here. I have x equals 1 over 2 of negative 1 plus or minus I root 3. Now, we can have two different solutions for x, that is x2 and x3, or x2 will be 1 over 2 times negative 1 plus I root 3, and also x3 will be 1 over 2 of negative 1 minus I root 3. So these two here are the complex solutions. And we have one real solution here, which is x equals 1. Now, as usual, the next thing we are going to do will be to check by inserting the real value for x, which is 1, into this original equation, which is x power 3 equals 1. So we are going to insert 1 here for x. So we have 1 raised to the power of 3 equals 1. And 1 raised to the power of 3 is 1. We have 1 equals 1. The both sides are the same. So that shows the potency of this particular solution. Now, that being done, for you to solve an exponential problem like this, the most important step to take is to ensure that the exponents are the same. And for you to ensure that, you have to express this one here in terms of the 3. This is 1 power 3, and this is x power 3. So right now, making use of this identity, we are going to expand. And we make use of this identity, which is a minus b times a squared plus ab plus b squared, in which a is x and b is 1, depending on the equation that we have here. So we insert those variables for a and b. And from here, we formulated two different equations. One is a linear equation, a is a linear equation, and this other one here is a quadratic equation. So to solve the linear equation is quite very simple. You move this number over here and make this a substitute equation. So, and that gives us a real solution. To solve this quadratic equation, we make use of formula method. You can also consider making use of completing the squares. It is not factorizable, so you cannot factorize it. So we write the quadratic formula, which is this negative p plus or minus square root of b squared minus 4ac divided by 2a, inserting the values of a, b, and c, gotten from this equation. A is coefficient of x squared, b is coefficient of x, c is the constant. Insert all of them here. Observe that you are going to have a negative number here, and square root of negative, is imaginary number I. Then from there, you simplify further. And this will surely give you two different solutions because you have plus or minus right here. So at the end of it all, you have two complex solutions, which are this one here and this one here. The thing is this one and this other one here, the second one here. So we also try to check the potency of that solution by inserting the original solution into this equation, and it actually satisfies the equation. So this is the brief summary of what we did, and that is it. Thank you and goodbye.